Good day, class. Today we will talk about sampling distribution involving central limit theorem and standard error. So when we say central limit theorem, it states that if more samples are taken from the population, the sampling distribution of the mean approaches a normal distribution. So the higher the number of sample size, the better. Okay? Like for instance, this graph is the distribution of the sample means wherein each sample contains 5 scores. Okay? The number of or the sample size is equal to 5. And we obtained this distribution. On the other hand, this graph, color blue, it is the sampling distribution of the sample means wherein each sample contains 30 scores or 30 sample size. Okay? So what have you noticed? Okay, on this graph, red graph, our sample means are scattered or they are dispersed or spread, alright? On the other hand, here, our sample means are closer to the population mean. Okay, because most of our sample mean is here, and that is close to our population mean. While here, on our red graph, we have sample mean here and sample mean here, and they are somehow scattered. Okay? So it means that it is best for us to have a sample that contains big sample size. Okay? So n is equal to 30 is better than n is equal to 5. Okay? On central limit theorem, that is just a concept wherein we will connect that concept here on the standard error. Okay, so when we say standard error, it is also the standard deviation of the sampling distribution of the sample means. Okay, so last time we've discussed about variance of the sampling distribution. Means if we find the square root of that variance, that is what we call the standard error, since the square root of variance is the standard deviation. Okay, so the importance of standard error, they reflect how much sampling fluctuation a statistic will show. So in general, the larger the sample size, the smaller the standard error. So if we have a large sample size, we will be having a small standard error. Okay? So if we come up with small standard error, probably our sample size is big. Or if our sample size is big or large, therefore, we will be having a small standard error. What is a good standard error? So the smaller the standard error, the less the spread and the more likely it is that any sample mean is close to the population mean. Okay, so earlier on our central limit theorem, we've discussed about um, sample size. Okay, if we have large sample size, our sample mean is close to the population mean, right? Here, if we have a smaller standard error, the distribution is less spread and the sample mean is close to the population mean because we have a large sample size. So sample size matters in central limit theorem and standard error. So what is the difference between the standard deviation and standard error? Standard deviation measures the amount of variability or dispersion for a subject set of data from the mean, while the standard error of the mean measures how far the sample mean of the data is likely to be from the true population. So in standard deviation, um, we have the raw scores or the scores on the distribution, and we are able to measure the variability, how spread are those scores from the distribution or from the mean rather. How disperse those scores from the mean. On the other hand, when we say standard error, we will talk about sample mean. Okay? So it measures the variability or dispersion of the sample mean from the true population mean. Okay, how far or how near the sample means from the population mean. Okay, again, standard deviation talks about the raw scores. On the other hand, standard error is about sample mean. Okay, how disperse or the amount of variability of the sample mean. So let's talk about this example. Suppose a population has a mean 80 and standard deviation 10. Then we get a sample of 90 cases and the mean of this sample is 82. How frequently does the sample of 90 cases differ 2 or more points from the population mean? So in that case, we will look for the probability wherein the sample of 90 cases is differ by 2 or more points from the population mean. Because as you can see, our population mean is 80 and our sample mean is 82, right? So the difference is 2. But what is the probability that we will be having 2 or more points from the population mean? So here is how. To solve that problem, first, you have to identify the given. Second, you have to get the standard error using this formula. Standard error is equal to the population standard deviation divided by the square root of n, wherein n is the sample size. Then find the z-score, then graph. And to find the z-score, we will have this formula. Z is equal to sample mean minus population mean divided by the standard error. Okay, this is the standard error. So the value that we obtained here will be substituted or will be substituted here. Okay, so on the denominator, on finding the z-score. So let's solve the problem. First, we have to identify the given, and the given are population mean we have 80, population standard deviation 10, the number of samples or sample size 90. Okay, 90 cases. Then sample mean we have 82. Okay, so after that, let's find the standard error. So using the formula, we have population standard deviation is 10. Then divided by the square root of n is 90. 10 divided by the square root of 90 is approximately 1.05. So this 1.05 will be substituted to the denominator in finding the z-score. Okay, so find the z-score, then graph. So using this formula, we will be having sample mean is 82 minus 80, our population mean, divided by 1.05. That is our standard error. So if we simplify this, we will obtain 1.90 or approximately 1.90. This is our z-score. So after having the z-score, let's try to locate it on our table 1. Okay. So when we use the table 1, that is the area between the population mean and the certain z-score. Okay. So here, our first step is to look at the tens, the whole number and the tens place. So 1.9. Then here we have 0.00 because we have 1.90 as our z-score. So then take a look at the intersection, that is 0.4713. So the area between the population mean and 1.90 or z is equal to 1.9, that is approximately 0.4713. So let's graph that. Okay, so the area is 0.4713. Therefore, here on the left side, that is 0.4713 as well. So we are asked on our problem the how frequently does the sample of 90 cases differ by 2 or more points? 2 or more points. So if here we have um, the difference is 2, okay, since our mean or sample mean is 8, 82, then at our population mean is 80, so the difference is 2. Therefore, 2 or more points means to the right, okay, to the right of the z-score. So 1.9 to the right, okay, so we will shade this part, and we have noticed that the shaded region or shaded part is less than half of the distribution. So if less than half of the distribution, you have to subtract the area of the certain z-score and 0.5. Okay? So 0.5 minus 0.4713, that is approximately 0.0287, or in percentage, that is 2.87%. Okay? So this part of the distribution is 2.87% of the sample means. Okay? Or 2.87% of the sample means are here, okay? And 2.87% of the sample means are here as well, because the curve or the graph are symmetric, okay? So our interpretation for that is the probability that the sample mean differ by 2 or more points from the population mean is 0.0287. Okay? So, again, let's recall the steps. First, you have to identify the given correctly. Then, you have to find the standard error, because we will use that standard error to find the z-score. Okay? So, let's find the z-score. And to find the z-score, that is the ratio of the sample mean minus the population mean to the standard error, or sample mean minus population mean divided by the standard error. Then after having the z-score, you have to locate it on the table. Then you have to graph, or you have to illustrate the situation to find the answer, and um, you have to interpret your illustration or your solution. So that's all for today. Hopefully, you are able to solve, or you are able to apply the standard error in solving certain problems. Thank you so much, everyone, and God bless you.